Welcome to the Math 107 Lesson 17 demo. We're going to start today by creating new functions by combining two or more functions through the operations of addition, subtraction, multiplication, and division. So algebra of functions works almost exactly like you would expect. Okay, so f plus g of x just means add your f of x and your g of x. So all of this is pretty intuitive. The domain is the harder part. Finding the domain of any of these, it is the intersection of the domains of f and g. And then for the quotient, you also have to make sure that g of x is not 0 because it's in the denominator. Okay, so I'm defining f as 1 over x minus 2 and g as the square root of x. The domain of f. So the domain of a fraction is just all values except anything that would make the denominator 0. So this would be the set of all x such that x is not 2. If you put a 2 in for x, you would get 0 in the denominator, so we have to exclude that. So my domain is all values except for 2. So let's see, I'm going to put that's 0 on my number line, 1, 2. So I need to do everything, include everything here except for this value of 2. So I'm going to put a open bracket there and shade everything to the left. And then I also want to put an open bracket and shade everything to the right. So everything is shaded except for the 2. The 2 is excluded from my domain. The domain of g, well, that's a square root function. Anything under the square root needs to be positive or 0. So x has to be bigger than or equal to 0. So if I were to graph this, I would have a 0 here, and I would put a square bracket on the 0 to include it and shade everything to the right for bigger than or equal to 0. Now the intersection of the domain of f and the domain of g, that's where they overlap. Okay, those are all the x values that belong to both the domain of f and the domain of g. So 0 is in both, so I'm going to include 0. Almost everything to the right of 0 is included except for 2. So I have to not include 2. So I'm going to include everything from 0 to 2, including the 0 but not the 2. And then I'm going to include everything to the right of 2, but not the 2 itself. So that's my visually, I did the intersection by looking at where on the number line do I have both blue and pink. And then if I want to write that out, I would do it in interval notation. I would say 0 to 2, union 2 to infinity. Okay, so now I'm supposed to add f plus g. So you just add the formulas. F of x formula plus g of x formula, 1 over x minus 2 plus the square root of x. And you could try to get a common denominator and add those together, but it's not worth the effort. F minus g is going to be 1 over x minus 2 minus the square root of x. F times g is 1 over x minus 2 times the square root of x. This one you can simplify in one quick step, so I'm going to go ahead and do it. This becomes the square root of x over x minus 2. And f over g would be 1 over x minus 2 over the square root of x. And that I think I might also simplify, but I'm going to leave it like that for now. Maybe we'll come back and simplify it. So I did all of the operations. Now I just have to write out the domains. So for all of these, the domain is the intersection of the domain of f and the domain of g. 0 to 2, union 2 to infinity. And same for the product. And it's the same for the quotient, except I have to make sure, because g is in the denominator, g can't be 0. Right? So this this denominator of my fraction can't be 0, which means that x can't be 0 because the square root of 0 is 0. So this domain changes a little bit because I have to leave 0 out. So this is going to be a round bracket, 0 to 2, union 2 to infinity. Because I can't put 0 in or I'd have a 0 in the denominator there. All right, now I'm going to simplify this. 1 over x minus 2 times 1 over square root x. Just flip and multiply by the reciprocal. So this is 1 over square root x times x minus 2. All right, so that's my little intro on adding, subtracting, multiplying, dividing functions. We have one more way that we can combine functions, and that's called composing. That's where you use the output from one function as the input for another. So for example, I'm going to define two functions, m and f. M of p is the biological mother of person p, and f of p is the biological father of person p. M of f of p is referring to, well, f of p, that's the father of person p, apply m to that output, so that's the mother of the father of person p, or the grandmother. We'll say it's the paternal grandmother of person p. The mother of the father of p. All right, the sequential process of combining functions to make a new function in determining the family member, represented by m of f of p, is referred to as a composition of functions. For two functions, f and g, the notation we use is f and then this open circle g. So don't confuse that, that open circle with a dot, because the closed dot means multiplication and this open circle means composition. So that you would read that as composed with. And it just means use g as the input into f. So the order, it's very important to look at the order. The input of g is x, and then g is the input into f. So when you're composing functions, to evaluate a composite function, you always start with the innermost parentheses and then work toward the outside. And then finally, the domain of a composite function, f composed with g, is a set of all x's such that x is in the domain of g and g is in the domain of f. We'll do an example of finding that domain. Okay, so I've got two functions here. F of x is x squared and g of x is 1 over x plus 1. And I want to evaluate f composed with g at 3. So that means plug 3 into g and then plug the result into f. Okay, so I start at the innermost parentheses and work my way out. So my 3, that's an x value, and I'm going to plug it into g. So g of 3 is 1 over 3 plus 1, which is 1/4. So that means that f of g of 3 is f of 1/4, right? Replace the g of 3 with what it equals, 1/4. F of 1/4 is 1/4 squared, which is 1/16. All right, let's reverse the order. Okay, now I'm going to do g composed with f of 3. So that means 3 is still my x value, but I'm going to plug it into f first and then plug the result into g. Okay, so first I'm going to start by evaluating f of 3. That would be 3 squared, which is 9, which means that g of f of 3 is really g of 9. Just replacing f of 3 with the value that I calculated a minute ago. And then g of 9, that would be 1 over 9 plus 1, which is 1/10. So did the order matter? Yes, right? I did not get the same answer when I did f composed with g as when I did g composed with f. So my conclusion here is that those are not necessarily the same. F composed with G does not always equal G composed with F. Okay, same two functions. I want to determine a general expression for the composite function F composed with G of X. So G of X I know is 1 over X plus 1, which means that F of G of X is really F of 1 over X plus 1. Doing my substitution, I replaced G of X with its formula. Okay, and now if I want to take that formula 1 over X plus 1 and plug it into F, that means replace every X in the F formula with a 1 over X plus 1. So this is 1 over X plus 1 squared, which is 1 over X plus 1 squared. All right, let's look at a general expression for G composed with F. So F of X is X squared. So G of F of X could be rewritten as G of X squared. Right, just replacing F of X with its formula. But G of X squared means look at the formula for G, and everywhere you see an X, we have to replace it with an X squared. Right? If that X gets replaced with an X squared, then every X in the formula gets replaced with an X squared. So it's going to be 1 over X squared plus 1. All right, now I want to look at the domain of G composed with F. That's the domain of what I just found, the 1 over X squared plus 1. So for the domain of a composite function, you have to make sure that X can go into F and that F can go into G. So I'm composing G with F here. I like to draw two function machines, right? X goes into F first. I'm doing G of F of X. So you start with the innermost. So I'm plugging X into the F machine. So I'm going to draw a picture of a function machine called F. Drop in an X, right? Out comes X squared. There's no restrictions here. You can square anything. The X squared's domain is all real numbers. So there's no restrictions there. Then I have to take that X squared and plug it into the function machine called G. So I take that X squared, drop it into the G machine, and G is going to take that and do 1 over X squared plus 1. Now the only thing I have to make sure that I don't plug into G, right, because G of X, its formula is 1 over X plus 1. I just have to make sure that I don't plug into G something that would make that denominator 0. I can't put a -1 into the G machine, which is lucky because I can never get a -1 out of the F machine. Because F squares things, it will only produce positives or 0. So I will never put a -1 into the G machine as long as X goes through F first. So the domain of G composed with F is -∞ to infinity.